Now the gearbox is on the lathe, and I've got the new covers that I bought off of eBay. They're all installed now. And it works pretty well, except, boy, is it noisy. I'm hoping that it's going to run itself in a little bit. There's one gear inside the gearbox that is still die cast, a compound gear, and it's pretty worn, and I'm kind of wondering whether that's not the cause of the noise or whether it's the tumbler gears that are causing it, because they're still die cast. But let me turn it on so you can hear what it sounds like. That's pretty noisy. It's a little more quiet when you run it in the reverse direction. But obviously, most of the time, you're running the carriage towards the headstock. And this is what the lathe sounds like without the gearbox. So this part of the project has been completed. I'll show you some of the steps I've taken in rebuilding the gearbox later in the video. I will probably be doing most of my cutting with the DC drive that I put on the lathe, instead of listening to that noise with the quick change gearbox. So the way you use the DC drive is you have to first disengage the gearbox by dropping both sector arms, and then we turn on the DC drive, which has got the motor running now. The tumbler is in the neutral position. You pick up the handle, which engages the lead screw. And I don't even have to turn the lathe on to show you how quiet and nice it is. Ratchet it up to whatever feet per inch you want, from very slow to very fast. We're back at the lathe, continuing our project. I've taken off all of the change gears in the banjo and the cover and the other directional gearbox. It's all sitting down here. Banjo, gearbox. I'll keep them just in case, you know, you never know. I might want to go back to it. I don't like the quick change gearbox. I've already cleaned up the banjo, the tumbler, and mounted it on the lathe. It's not connected to the gearbox yet, so it kind of moves, but it seems to work pretty well. Gears aren't too bad. The two small gears are a bit worn, and probably at some point in the future will have to be replaced, but I think there's still a few more years left in it. Now I'm going to take you over and show you the gearbox and what I found. I'm working on rebuilding the Atlas quick change gearbox, and I've taken out the selector arms. When I did, I found that the shaft, or spindle as I think the parts list calls it, is completely worn. I don't know if you can see it, but where it runs through the bushings, it's over 10 thousandths undersized, and there's all these ridges along the whole length wherever the selectors were. So what I discovered was that somebody in the past has rebuilt this already once, and they put in oil-like bushings, but they didn't drill a hole in the bushing for the oil. You put the oil in the cup and it can't get to the bushing because there's no hole in here. So it just wore the bushings. The bushings are about 10 thousandths oversized, and the shaft is about 10 thousandths undersized. So what I've decided to do, I have a lot of cold rolled 5/8 inch material. I'm going to make a new shaft, and it's a very simple project. All I got to do is cut the length, face the two sides. There's a keyway cut in here, and this is a hole where a tapered pin goes, like that, which basically just keeps these selector arms from crossing over to where they shouldn't be. So I don't have a taper pin reamer that small. I have the next size, and so I haven't decided if I'm just going to put a larger taper pin in or I'm just going to use a simple roll pin. I don't think it really matters. You can only be so much of a purist. Sometimes you got to be practical. So that's what I'm going to do. I'm going to make a new shaft and then get all the arms and stuff cleaned up and the gears cleaned up, and then I'll move on to the next part of the gearbox. But we can see already that this shaft is also worn, and there's quite a bit of play. So I'm expecting to find the same thing on this shaft. looks good. So I've decided I was going to change all the bushings. The problem that you run into is that this is all die-cast material, and if you start hammering or trying to punch these bushings out, you're likely to crack it. So what I did was I turned a little extractor on the lathe, so the minor diameter is a little less than 5/8, or 0.625, and the major diameter is a little under 3/4 with a 5/16 18th thread in it, and it works quite well to pull them out. I'll show you how this works. You take the selector arm and you push the extractor in to that little piece there, and then you take the stud and screw it in, and then we take a socket that has at least a 3/4 inch opening in it, little washer, and a nut. Tighten them up, get it all centered nicely, and a wrench. And there it goes. It just let go. And there you have it. No pressure, no banging, no nothing. Now, once I get the new bushings, I'll use the same piece to install them. I would put the bushing in here and put this way in there, and take the original gear that was in there, which is a pretty close fit, and use it as a spacer like that, and then pull the bushing in so that I don't put any pressure on the die castings. So I thought that might be helpful. I'm going to do the same thing on here. I'm going to use the same extractor and pull the bushings out, and then reverse it and pull the bushings in. I've replaced most of the bushings on the gearbox housing here. Half by 5/8, 5/8 by 3/4, and the same on this side. I used my little pullers to install them by using them in reverse, putting them in this way, and then putting a washer and a nut and cranking it in with a wrench so that I didn't put any stress on the housing or the castings at all. Now I have to put the bushing in here, which holds the final, I guess, drive that the lead screw slides into. And I wasn't able to get the proper size bushing. I had got the right ID, but the OD is about 1/16 of an inch too big, and I have to turn that down. I'm going to show you how you can turn down a bushing without crushing it, which is what I did on all of these. They all had to be turned down a little bit because these are bronze, they're not oil-lite, and bronze bushings usually come anywhere from 2 to 3 thousandths over, and I didn't want to put any undue pressure on the housing, so they were sized to just 1/1000th of an inch above the ID of the housing. So this is how I go about doing it. I take a little mandrel that will fit the bushing that I'm going to be working on. Take a little red thread lock, whatever brand you like, and you really only need about a drop or two, and then put the bushing on it. I'm going to leave it sticking out a little bit so that I can trim the length. Turn it a little bit to distribute it and wait for it to harden up. Then we can chuck this in the lathe, turn down the outside diameter, and I'll show you how you get it off when we're done. Well, now we're at the lathe. I've got the bushing and the mandrel in the chuck, and I've got to turn this down to 1/1000th over 1 inch. All right, 23 thousandths. All right, we're at 3 thousandths. Has to come. We're going to go one. We have to take 2 thousandths of an inch off. That's it, right on the money. 1/1000th over 1 inch. Very cool. There we go. Now I'll show you how to take it off. There you go. Comes right off for a little heat. Alright, so now I got to drill, I have to drill an oil hole to match up with the oil hole in the housing, and then we're going to press it in. Alright, now we're going to install the bushing into the housing. So, the oil hole, where is the oil hole? The oil hole is on the side. I want to, I have to make a mark there so I can see it. Right there. So the bushing is going to have to go in with the hole over there. Alright, so we take what I used to pull them out, put on a washer, a little smaller washer, a nut, let's crank it in. Okay. We're good. Okay, think we're ready to put the gears back in. I'm working on the covers, the gear covers for converting the lathe, and somebody drilled a series of holes in here to mount a reversing switch. And I'm going to fill these up with some aluminum and finish it off. I'm going to use my TIG torch. I have some filler rod, and I'm using my Miller Synchro-Wave 180. It's set at 160 amps. Balance somewhere around 3. I think that's worked for me in the past on cast aluminum, so hopefully it'll work today. Good enough.